as we have studied in last class, like what is the formula for torque? So already we know the formula for torque, tau is equals to R into F. And last class we have derived tau is equals to moment of inertia into angular velocity. So we derive this formula and we have solved many sums to calculating what is angular velocity, sorry, angular acceleration, and as well as we have found angular displacement. So I have taught many sums, even including the JEE sums also we discussed it. So in our today's class, what is our target? The next most important concept for JEE actually. So, and as well as NEET also, that is only hinge forces. So hinge in the sense of the pivoted point. So we all knows the pivoted point. Am I right, everybody? Pivoted point means where the whole body will be attached to a particular point, where it will be based upon that point, it will be take the rotation. Am I right or wrong? Pivoted point, everybody. So that pivot point is only we used to called as hinge point. What is to call all of you? Hinge. Okay.
Hinge point.
So hinge or pivot point, same. Now you can see if when you are opening or closing the door, for example, this is what is our entrance, house entrance. So we'll be having a door. Now this door is attached to this with the help of hinges. Do you all remember everybody for opening and closing it? All of you, please respond.
Yes, sir.
That is only called as pivoted. The pivoted point means that is only called as hinge points. So now we are going to study about what is this hinge forces. Okay. So, and how to calculate it. That is all the things we are going to discuss in our today's class. So this is also one of the most important concept for JEE mains and as well as NEET. We will see with the help of numericals, we'll make it. Okay. So keep adding, all of you. Hinge forces, rigid body dynamics. Okay. So now let us start with the question itself and you can able to do it one by one. So already two things we like calculating angular acceleration. You are all familiar. Many questions we have solved in the last class. But now we are going to see that. So write question number 1. So let me take, there will be a rod who is having a length L and it is pivoted at this point. Clear everybody? And here perpendicularly the force has been applied. This is only the question. Clear everyone? So we have to calculate it. Problem number 1. Find angular acceleration of rod. Sorry. Angular acceleration of rod. Second one. Acceleration of COM of rod initially. Initially, be very careful. Initially it is. Next, third one. Reaction forces. Reaction forces affected by hinge. The hinge only we used to call it as what, everybody? Pivot to the rod.
Point.
So this is only the question. Now first we can find angular acceleration. So as you are all familiar, angular acceleration. So first let us see how to find it. So we all people knows tau is equals to, what is the formula, everybody? Tau is equals to
I angular.
Yeah, I alpha. So let us draw the diagram again. So it has been pivoted point. So pivoted point to the force is applied here. So then along the pivoted point. What is the moment of inertia? Anybody? Along the pivoted point at the edge. What is the moment of inertia?
ml square by 3.
ml square by 3.
ml square by 3. And what is this distance, Mr. Sai Karthik? R. That is only R is equals to what is that, guys? L. Clear, everybody?
L.
And applied force is F. So a rod having a mass M and length L. See, very few people are only there. Many people not wake up. At least you all can say, correct? That's what it is. You can make it. So I will say tau is equals to I. So what is I value, everybody?
ml square by 3.
by 3 into alpha. And what is the tau? Tau, another formula we all knows that. I'm hearing Ishali. So tau, another formula we all knows. What is another formula for tau, everybody? Tau, another formula. Please respond. R into F. Understand? So you have to write. So R into F. Mr. Murali doing So now we all knows that R is equals to what, guys? R is equals to what, all of you? L. So L into F is equals to ml square by 3 into alpha. Now something will get cancelled. What will get cancelled, everybody? L and L will get cancelled. So alpha is equals to 3 will come this side. 3F divided by, what will happen? 3F divided by
M.
L. So this is the angular acceleration. Anybody having doubt? Please let me know. So just make it. Please ask. Clear, all of you?
Yes, sir.
Sir.
This is things. Now, you have to be very smart here. Mr. Rishi, can you hear me? All of you observe. Now they are asking next one is what? Acceleration of COM rod initially it is taking place. So imagine that if this rod force is applying, it will be keep on making into circular motion only. Am I right or wrong, everybody? Will you all agree with me? Please respond, guys.
Yes.
Yes. Now
Yes, sir.
initially, so let me consider, basically I'm saying you, if I take a rod, all of you observe, if I take a rod, through center of mass they are asking. So center of mass means this is what we used to call as COM. Am I right or wrong? Everybody? Hinge is present
Yes,
at the last. So through center of mass it is asking. Just imagine if this body is, the force is applied like this will be started making into circular motion like this. Am I right or wrong, all of you? Will you all agree with me?
Yes, sir.
Please respond. Now, if it is making a circular motion, at any point if I have taken, the acceleration will be, one acceleration will be like, velocity will be like this direction. So velocity means body is accelerating. That acceleration we used to call something tangential acceleration. And there is an acceleration which is acting towards to the hinge. What is that, everybody? Yes, please. Centripetal acceleration.
Centripetal
Everybody? Yes or no? Please respond.
Yes,
Any
sir.
point you can take. If I take here, this is the tangential acceleration. And perpendicularly to that, which will acting towards the center. What is that, Mr. Rudreshwar? Sorry. Sai, are they clear? Rishi? Centripetal acceleration. Now just imagine, guys, it has been made. What they are asking? Acceleration initially. So initially means, just imagine this body has been just shifted little bit initially because of applied force. Now, all of you observe very carefully. Imagine that it has been made 10-degree angle per 1 minute. 10-degree angle per how many minutes, everybody? 10-degree angle per
1 minute.
That is what angular acceleration. Now, angular acceleration remains constant or not? All of you verify. For example, this is the initial position of the rod. Now, for the force is applied. Due to the applied force, it has been small distance, it has been marked. Now, through the center of mass, tangential acceleration is acting, and there is acceleration which is acting towards the what? Center. What is that called as? Centripetal.
Centripetal acceleration.
So now they are asking for everybody observe. Now, if I make, for example, this is the angular acceleration made. Now, if I measure anywhere, angular acceleration remains constant here or here or here or here. Everywhere angular acceleration remains constant or not? Everybody? Please
Yes,
respond.
sir.
Yes.
Yes, sir.
The theta, basically we can discuss. The theta is remains constant or not. Here or everywhere you can check it. Theta is remains constant or not. All of you, please respond.
Yes, sir.
So alpha remains same. If it is making angular acceleration remains same. Now at every point, what acceleration will be there? Tangential acceleration. So to the COM, two accelerations are there. One is tangential acceleration, and next one is what? Everybody.
Centripetal
Centripetal
acceleration.
acceleration. Okay. Now first tangential acceleration. What is the tangential acceleration formula? Everybody. R
R alpha.
alpha. Now tell me, Aksha. R means distance. So till the center of mass. They're asking till center of mass. What is the distance? Everybody. Yes, total length is L. That's till center of
L
mass.
by
What is the distance?
L
Everybody.
by 2.
L by 2.
L by
Very good. L by 2 into what is the alpha value? 3F
3F by M.
by
3F by ml.
3F divided by ml. So LL will get cancelled. What is the answer? Everybody.
3F by
3F by 2m. This is tangential acceleration. This is tangential acceleration. Now, what about centripetal acceleration? This is what when it will make initially after acceleration of COM of rod initially. So initially, as soon as the force is applied, what is the angular velocity of the body? As soon as the force is applied, at the time of force applied, you can see force applied. What is the angular velocity? Angular velocity of the body is equal to how much, guys?
0.
Please, at the time of initially applying,
0.
angular velocity is equal to how much, everybody?
0.
0.
Equals to 0. So angular velocity is equals to 0 means at everything you can see. So what is the centripetal acceleration formula? Centripetal acceleration is equals to r omega square, or we can say v square by r. So angular velocity is 0 as soon as the force is applied. So that centripetal acceleration will become what? Everybody?
0.
0.
0. So that is what you have to find it. So acceleration through the COM. So two accelerations. One is tangential acceleration, another one is centripetal acceleration. I hope you all understand. Anybody having any doubt, you can ask me, or else you can. Clear, everybody?
Yes, sir.
Yes, sir.
So now we want to find net acceleration. So what is the way to find the net acceleration? Everybody, net acceleration formula, please. Murali, tell me net acceleration formula. So net acceleration is equals to what is the formula, guys? Root over AC square plus AT square.
80 square.
The formula. So you can do that one. You can get the net acceleration. Okay, everybody. So net acceleration means what? Tangential acceleration is acting some direction, and centripetal acceleration is acting some other direction. Now resultant means net means will act here only. Am I right or wrong? Everybody?
Yes, sir.
Yes, sir.
If you want to find the direction of net acceleration, so you can find, we all knows that net acceleration equals to root over square of tangential acceleration plus centripetal acceleration. That's all it is. Clear, everybody? Anything doubt, you can ask. Okay. Next, third part. This is only is our today's class importance. What is that today's class important? Calculate the hinge forces. Understand?
Hinge.
All of it. So that is what is very important. Now, let us observe before going to find that. So we all knows that the given one is a rod where it has been pivoted. So that pivot point only we can call it as a what point? Everybody? It is called as hinge point.
Hinge point.
Now,
Hinge point.
observe, if I take this is the hinge point. Now, please make attention. Now you can see if I consider basically, if there is a block is present on the surface, then what is the normal reaction exerted by it, everybody? Normal reaction exerted by the surface. It will be upward direction. Just simply,
Upward.
yeah, it is a normal reaction. If it is the inclined surface, for example, if it's the inclined surface, we have done it already. So what is the normal direction? Perpendicularly to the surface. Am I right or wrong? All of you? So weight of the body is acting downward direction. That is what mg. So this is what mg cos theta And this will become what, everybody? mg.
mg sin theta.
mg sin theta.
Then what about the normal reaction perpendicularly to the surface? This is only called as normal. Am I right? Everybody, please respond.
Yes, sir.
Yeah. Now, same way, hinge forces, remember, hinge basically it is a three-dimensional one. So that is why you can see here we can only see two-dimensional. So hinge means the normal reaction will exit in two different directions. One is upward direction. Let me take that is one, and which is acting. Another one is towards to the center. So that is what two different normal reactions. One is N1, another one is N2. One is N1, another one is what? Everybody? N2. So this is what hinge forces. Normal forces. One is towards the center, another one is towards to the upward. This is only called as what? Hinge forces. Now, if you want to understand this one, so let us draw the FBDs. What do you mean by FBD? Everybody, free body diagram.
Free body diagram.
Then you can understand it. Okay. So let us take the first one. So we all knows that the body is revolving. So revolving means at every point there will be acceleration. So what is that? Through the center. From the center there will be acceleration if I consider. What is that? Tangential. Just now we have calculated tangential acceleration. So it is pivoted so that there is a acceleration. Sorry, there is a reaction force, normal reaction, and the applied force is what? Everybody. Applied force is what? F. Am I right or wrong? Please respond. All of
Yes,
you.
sir.
So now you can see that. Forget about the acceleration. So applied forces FBD I have drawn. Tell me, both N2 and F both are same direction or opposite direction? Same direction or opposite direction? Same direction. So N2
direction.
plus F, which is equals to, that is what? F net is equals to MA. Okay. F net is equals to MA. MA or MAT, tangential acceleration. Everybody?
MAT.
MAT.
Yes.
N2 plus F is equals to M into tangential acceleration. So that's all it is. Now, you all can see that. So you can easily find it. So we all people know what is that hinge forces? N2 plus F is equals to mass is M. So what is the tangential acceleration? You have found it, everybody? What is the tangential acceleration you calculated?
3f by 2m.
Yes, please. All of you?
3f by 2.
3f by 2m. 3f by 2m is the tangential acceleration. 3f divided by 2m. So now mm will get cancelled. So now what is N2? N2 is equals to 3f by 2, and this plus f will come, this side will become what? Everybody? Minus f. So N2 is equals to 3f minus 2f divided by 2, which is equals to f by 2.
F by 2.
So what is the hinge force? Hinge force N2 is equals to f by 2. Now, we want to make N1. So let us see N1. So again I will draw FBD. So now only see FBD of N1. So N1 is acting towards the what, as I said, everybody? N1 is acting towards the what? All of you? Towards to the center. And there is a, from the center, there is a force which is acting opposite to that. What is that? Centripetal acceleration. Are you clear, everybody? So now, both are opposite direction. So can I say action is equals to reaction? N1 is equals to minus MAC. Opposite. Opposite both. So, and we all knows that centripetal acceleration is what? Everybody. R omega square. Omega is equals to 0 at initially. So, initially omega is equals to 0. So that entire centripetal acceleration is 0. So that normal reaction is equals to what? Everybody? N1 is
0.
0. So that is the hinge forces. So this is what, how you need to solve it. What are the hinge forces and what it will be acting. Do you clear, everybody? All of you?
Yes, sir.
So finding the hinge forces. So same three questions, another one. Now in this case, see, pivoted point is given. The rod is pivoted at the corner. So now let me take the same one. Now the rod is pivoted at the center. Then what kind of things will be there? We'll calculate. So this question, if you understand, I hope everybody clearly. So then we will proceed with the another thing. Any doubt, anybody can ask me. Are you clear, guys? Everybody? Yes, please.
Yes, sir.
Yes, sir.
Please make it. Anything doubt, you can ask me. Clear, everybody? Understand, ma? All of you?
Yes, sir.
Sir.
Murali, are you trying? Rishi?
Yes, sir.
Okay. So next. Now same question. We have to do it in such a way. So what is the way we will do it, everybody? Now it is pivoted at the center of the mass. So let us see that how it will be happens and how it will be going to make it or not. So again, same thing. So find angular acceleration of a rod. So now, all of you observe a rod. You try only, you will get it. If not, nothing will happen. So it has been pivoted at the center. And the applied force is 37 degrees. 37 degrees in the inclination. So we are all very familiar with the 37 table. So what is the 37 triangle? Angle 37 means shorter side 3, longer side 4.
4, 5.
So next cos 37. I don't want to say, you should tell me. Cos 37 value, please.
4 by 5.
4
4
by
by 5.
sin 37 value.
3 by 5.
3 by 5. Okay. So you have to be careful. So now this is the question. Okay. That's all it is. Now having a rod mass M and length L. So all of you please start solving. Any doubt you can ask me. Mr. Murali, are you doing? So we all knows that. Immediately first I'll say, so as everyone knows, here force is acting inclination angle. So that immediately it will be splitting into how many directions, everybody? Force will be splitting into two components. What is that? X component and everyone?
Y component.
Y component. So now X component and Y component, verify. Here is the theta. So here what will happen? Everybody. F cos 37
Cos theta.
and here F
F sin
Sin
37.
37. Modify. Again you draw the diagram. So if I modify it, so middle component will go off. So this is my rod. This is my rod. So force is exerting two different components. One is X component, another one is what component? Everybody?
Y
Y
component.
component.
Y component.
This is the force and this is the another force. So this will become what? F cos 37. So F cos 37 value, how much ra? Cos 37, 4 by 5. So
4
what
by 5.
happened? 4F divided by 5. And this one, F sin 37. F sin 37 means F.
3 F by 5.
So 3
3
having a mass M and length L. So okay. So along the pivoted point, so we all knows that center of mass. What is that? Moment of inertia through center of mass formula. Everybody.
ML square by 2.
ML
ML
square.
square.
Okay. So that's all it is. So you can find the angular acceleration. So we all knows that tau is equals to
I alpha.
I alpha. So I means I through center of mass. What is that? ML square.
ML square
ML
by
square
2.
by 12.
Another formula for tau R into
R
F.
into F.
Now
R into
R
F.
value how much, guys? Everybody check it. R value how much? L
L
naught.
by 2.
L by 2. Okay. So please remember R is equals to L by 2. Mr. Rishi, are you able to understand it? So L by 2 into F, which is equals to Sai Karthik, ML square by 12 into alpha. So L and L will get cancelled. Now next what will happen, everybody? 2 ones are 2 6 are. So now alpha is equals to 6F divided by 6F divided by what? Everybody? Okay. So that is what is the angular acceleration which you have been found. Any doubt? Anybody can ask me. Are you clear, guys? All of you?
Yes, sir.
Yes, sir.
Next. Any doubt you can ask me. Next. Second subdivision. What is that? Acceleration of COM of rod. I'm not putting initially. There is no word initially. Now you can check it, everybody. So now, all of you observe very carefully. So at the COM, so hinge is also present where? Hinge is also present at the COM only. Am I right or wrong, everybody? So it is a pure,
Yes, sir.
it is a pure rotation. Am I right or wrong, guys? It is a pure rotation, means whole body automatically. If this body will goes up, this body will come down. So it will make a complete pure rotation. So pure rotation it is. So what is the formula? Two accelerations. One is tangential acceleration and another one is what acceleration? Everybody.
Centripetal acceleration.
Centripetal acceleration towards the center only. Am I right? Everybody?
Yes, sir.
Yes, sir.
Please respond. So what will happen? So tangential acceleration equals to R alpha. What is R, Lakshya, here? Tell me. What is R? Anybody? See, if the hinge is at the last, then COM from the center of mass, we can take R is equals to L by 2. Now hinge is also at the same point and the tangential acceleration also through the center of mass. Then what is R? Here R means R is equals to L by 2. Now here in the case of this, what is that R? Everybody. R is equals to how much? 0. Are you clear? Hinge is exactly at the
Yes,
depth.
sir.
R is equals to 0 at the COM, center of mass. So the tangential acceleration is what? Everybody, pure rotation it is.
0.
Acceleration is 0. Next, centripetal acceleration. So centripetal acceleration equals to what is the formula? Centripetal acceleration. All of you. Centripetal acceleration formula, guys. You have written. What is the centripetal acceleration formula? Yeah, R omega square. Then what is R here? Two formulas we have. What is
0.
R formula? R omega square. So R is equals to again 0. So R equals to 0 means centripetal acceleration equals to also what? Everybody? 0.
0.
Remember, it is called as pure rotation. So in pure rotation, centripetal acceleration and tangential acceleration both are 0. I hope you all understand. Anything doubt you can ask. Mr. Udreswar, good morning. Very late. Okay. Clear, everybody?
Yes, sir.
Yes.
So that is what you have to remember. So now we have to find the hinge forces. So we start finding hinge forces now. So that is what third subdivision. So very, very important. So what will happen, everybody? Reaction force affected by hinge. So this is only important. What do you mean by hinge, everybody? Pivot. So
Pivot.
pivot to the rod. Okay. So that's all it is. So as I said now, hinge means the normal reactions reacting. How many it is, you can see that. So two normal reactions. Understanding, all of you? So let me take first normal reaction. It is N1. Now applied force, you can see that. Applied force is what? In this direction. 3F by 5. So FBD, guys. I'm drawing FBD. So now 3F by 5 and another acceleration, tangential acceleration. Tangential acceleration equals to what? 0. So if I
0.
draw FBD, so then what will happen? N1 plus 3F by 5, which is equals to M into tangential acceleration. So as tangential acceleration 0, so N1 is equals to minus
3F.
5. So that is the normal reaction. Anybody having doubt, you can ask me. Are you clear, everybody? All of you?
Yes, sir.
Next one it is. So next one you can see. So there is a force which is N2, okay, always. And there is another force which is acting here. What is that force? Everybody, 4F by, yes, please. Again, FBD you can draw. You can draw FBD, so we all people knows that from the center, there is a normal reaction N2, and there is a force which is applied. What is that, everybody? 4F by, 4F by.
5.
So now you can see, all of you. So you all can notice it. As we all know, centripetal acceleration equals to what, everybody? Centripetal
Zero.
acceleration
0.
equals to 0. So now these both are same direction or opposite direction? Same direction or opposite direction?
Opposite direction.
Opposite direction.
Opposite.
N2 minus 4F divided by 5, which is equals to mass into centripetal acceleration. So centripetal acceleration is 0. So that N2 is equals to what will happen?
4 by 5.
4 by 5.
So this is how we have to find the, okay, hinge forces. Okay. Now we have to find reaction force. That is what net resultant force. So net reaction. So what is the net reaction force formula? So we all people knows. What is the net resultant force formula? See, N is acting upward, N1, and N2 is acting downwards. So like this. Now you tell me. And also see, N1 is negative or positive? N1 is negative or positive?
Negative.
Negative. Negative means this arrow upward or downward? Negative, opposite. Downward. This is N1. This is not N1. So resultant force will act here. Am I right or wrong? Everybody? Yes, please.
Yes, sir.
Respond.
Yes.
So N2 is 4F. 4F divided by 5. N1 is 3F divided by 5. So net 4. What is that, everybody? Net reaction. Net reaction is equals to root over N1 square plus N2 square, which is equals to C, N1 square, 3F by 5 whole square plus N2 square, 4F by 5 whole square. So which is equals to, all of which are 3F square means 9F square divided by 25. Here 16F square divided by 25. Clear, everybody? Please respond. All of you, which is equals to. So this will become 25. Here up also will become 25F square. So 25, 25 get cancelled. Root over F square. Square and root will
Yes.
get cancelled, which is equals to what, everybody? Please respond.
Yes.
Reaction. Net reaction is equals to F. So any doubt you can ask me, guys. Are you clear, everyone? Mr. Rudreswar, understand hinge forces always act. Our today's class is only for calculating hinge forces. So how to calculate hinge forces only is our work. Clear?
Yes, sir.
So please do. You should work. So all of you find it. Anything doubt you can ask. Now, solve this question first. Everybody solve. Then only we'll proceed further. All of you understand? Mr. Murali, Rishi, Princey,
Yes, sir.
Yes, sir.
you must solve. See, this is one of the concepts are clear. Solving is very easy. See here why N1 is downwards, because N1 we got it negative. So negative means it is acting minus Y direction. So that's why it is minus downwards. So that is like small things if you are be very careful. So exam, no errors will happen. So that's all it is. So resultant force will be acting in this direction. So that is what resultant force is equals to F. That's all. Clear, everybody? Now, so
Yes, sir.
it's similar questions you can find every year in JEE and as well as NEET also. So imagine now there is a rod. All of you observe. There is a rod. Now you have to find it. Okay, you have to tell me, and you can join back in the meeting and we'll continue. So there is a rod, and just it has been released. Understanding, Rudreswar? It is just released. So released means there is a force which is acting downward direction. What is that force, everybody? Yes, please. Just released. What is that?
Weight.
Weight of the body. So it is a clockwise or anti-clockwise. See that it is moving. Clockwise or anti-clockwise? Everybody? Clockwise.
Clockwise.
Clockwise. Now, so that's all. For this one only, we have to find all these three. One is alpha. Next one is acceleration. Next one is what? Everybody? Third one.